400G networks, I guess, where are we right now in terms of the technologies that are available to make it happen? Can you give us a sort of overview of that?
Hey, yeah, thanks. Thanks. That's a great question. So 400G was even as near as, say, 9 months ago, it was the nascent technology that was going to take off here in 2020. And a couple of reasons for that is there's a new round of, or a new level of optical modulation, if you will, PAM4 modulation, have been really started to roundly be adopted to allow higher modulation, better encoding, to be able to send more data down the light stream. And switches are being introduced into the market. So optical switches, optical routers from the big NEMS manufacturers that allow for, basically for it to happen, right? Without those switches in the market, you couldn't have 400G. Now those switches are being introduced here in 2020, but as we all know, we've got a little bit of a speed bump, if you will, in how things are being adopted, and a lot of enterprises and perhaps service providers were looking at ways to maybe not no longer in their plans to deploy, but I think at the data center level, at say hyperscale content, I think that's really starting to be I think it's really starting to be a real prominent technology. I don't know, John, what you have any different thoughts on that topic?
No, I think you nailed it, Ray. The pandemic has certainly affected deployment plans across, I think, service providers in particular, in that lab environments and some of the testing that would be done has been very difficult this year. And service providers have been racing to add capacity to their networks. And in many cases, the easiest path was adding more 10 or more 100 gig interfaces to the existing backplane. So I think 400 gig took a little bit of a back seat for service providers in particular, but the technology continues to evolve. So full suite of DACs and AOCs have hit the marketplace, and certainly we're offering as well as transceivers. You nailed it. The hyperscale data centers have to do these upgrades. 40 and 100 gig links are becoming saturated. The amount of video and teleconferencing that's happening right now because of the pandemic that's driving that service provider upgrade is even more real inside of the data center, where you're replicating these video streams, like the very one we're recording now, is consuming just tremendous amounts of bandwidth. So 400 gig was, I think, certainly got derailed a bit in 2020, but we're seeing an uptick in the data center now. And I think, going into 2021, we're going to see large scale SP transport network upgrades.
Okay, and in terms of the actual sort of infrastructure investment required, I mean, just thinking about the sort of 4G to 5G transition, one of the major stumbling blocks seems to be the fact that you've got to put in a whole new set of infrastructure. You can't simply upgrade from 4 to 5G without putting a load of kit. What's the situation from sort of 100G to 400G? Is there a similar sort of forklift upgrade required, or can you easily migrate from 100 up to the 400?
I think the fact is most of the upgrades for 400 gig are new devices. So whether it's a new chassis with new line cards or a new pizza box or standalone switch, the major equipment manufacturers that were shipping last year weren't by and large shipping 400 gig interfaces. So we're seeing, significant for chassis based devices, significant upgrades either in the management cards or the fabric interconnect cards. Certainly the line card itself is an upgrade. I think what's really interesting, and Ray can probably speak to this, is 400 gig has some really nice breakout options. So the ability for service providers or data centers to reuse those 100 gig interfaces that they've already invested in with a new transceiver, and use aggregate or breakout from new 400 gig cores. So, really natural hand-me-down. Put 400 gig in the core of the network, push that investment, that 100 gig investment down one notch into the aggregation or access layer. And Ray, you want to talk a little bit about the 400 gig FR? Or 100 gig FR?
Yeah, absolutely. So as you mentioned, John, the 400 gig is just not going to appear in the cabinet tomorrow. It's going to grow from the core and work its way out there like some giant blob or something like that. Anyway, you'll start out with 400 gig in the core, and you'll break it out to 100 gig connections. Now, the interesting thing about 400 gig that a lot of data centers in particular right now are understanding is that if you have a 400 gig breakout transceiver, which breaks out to 4 100 gig connections, if you will, those are not going to be 100% interoperable with some of the transceivers they're going to have installed in their current network. The previous generation of transceivers use an NRZ, non-return to zero formatting, whereas the 400 gig transceivers use the PAM4 modulation, as I mentioned earlier. So there's a whole host of new transceivers being introduced, which are actually single wavelength. So 1 by 100 transceivers that have that PAM4 modulation that now are allowing that aggregation of multiple 100 gig streams back to a 400 gig port. So it's a 4 by 100 breakout using that PAM4. And then on these transceivers actually have a bit of a gearbox inside. So that gearbox allows them to do that PAM4 to NRZ conversion inside the transceiver. And that way, your legacy switches, as John mentioned, they can be used in your legacy switches. So that's a really interesting thing that we're finding here in this 400 gig is this notion of everything just kind of flowing back upstream to really aggregating at that 400 gig port.
And in terms of what end users, I mean, if you can summarize maybe what end users have to understand in the planning to upgrade to 400G, that would be useful. And also maybe as a supplementary, data center design. Yeah, I think you've alluded obviously to some of the issues, but I'm wondering what other changes might be required. I mean, is it multi-mode to single fiber as one possible? I mean, can you give us some of that landscape? Maybe start with Ray.
Okay. Yeah, great. One thing you hit the nail on the head there. One of the big transitions we are seeing is a transition from multi-mode to single mode fiber in the data center. Single mode fiber really represents, at this point, we still don't know what the limitations are going to be in single mode fiber. Whereas a multi-mode fiber, we're very aware now what the limitations are. So being able to go to a duplex fiber for your 400 gig and 100 gig connections, even in a shorter reach scenario, is really what the data center operators are looking for. They're looking for that level of simplicity. Whereas starting with 40 gig, 100 gig, especially now 400 gig, you need to use the MPO connector, different multi-fiber patch cables, all sorts of things that bring new complexities into the data center design. So that's probably one of the big things that we're seeing. I don't know, John, if some of the things you've seen.
Yeah, I think the single mode transition is probably one of the largest impacting. So you've got data centers that have been built over the last many years with structured multi-mode cabling infrastructure. And so the idea that to go 400 gig and beyond, we're really looking at single mode options to kind of stretch the capabilities of the transport layer is huge. We underestimate the cost and complexity of upgrading cabling infrastructure inside of a data center. It's quite a more time consuming and involved and risky than replacing even routers and switches or transceivers. And so I think, Ray highlights that point really clearly. I think the other piece as we think about 400 gig is as bit rates continue to increase, both at the server layer in a hyperscale data center, all the way up through the aggregation layer and into the core switching fabric, is thermal concerns. So these 400 gig routers are getting denser and denser. The transceivers aren't getting larger, but they are getting higher bit rate and higher power. And higher power equals higher heat dissipation. And so the idea that, we face this with virtualization and high-end compute where, racks were designed for 1 kilowatt and then 3 kilowatts and now 6 kilowatts. I think we're going to see racks need to scale way beyond that in terms of, thermal capabilities to accommodate what will be 400 gig in mass and in volume in the near future. So I would suggest the data centers have a couple of challenges ahead of them with 400 gig.
I mean, it just occurs to me, it might be a stupid question, but I mean, the high performance compute guys are looking seriously at liquid cooling, within the server at the chip level. I mean, is it conceivable at some stage in the future that liquid cooling for network switches or other network components, or is that just a sort of a nonsense? I mean,
that I've spent my entire career in service provider. We've talked about the idea of a liquid cooled or any type of alternative cooled router or switch, even transport. I think the economics of it are still a bit prohibitive. So, and there's some risk if you have these large cooling loops. We see liquid cooling loops today for HVAC systems, and the challenges with keeping water inside the pipes. I think that's probably the biggest challenge. And now you talk about extending that same liquid cooled infrastructure all the way into the rack, and the ability to circulate that liquid successfully without a spill or without seepage, I think becomes a bit challenging. So now, you've got a network element that might have a power connector or many power connectors. You have a network element that's got lots and lots of fiber connectors for its interface, and now potentially a liquid connector to connect it into a centralized cooling loop. So just putting liquid inside the box doesn't really cool it. You need that liquid to circulate outside the box through a cooling loop and back to get real benefit of scale. And so now you've got to plumb in your network elements and plumb in your servers just as you would from a network and power. And so I see some challenges there. Liquid and electronics have never gotten along too well. So the more liquid you put in and around them, I think the more risk comes with that. To your point, though, it also comes with scale and the ability to dissipate heat, in such a way that air just can't do it. Ray, you have thoughts on that?
Yeah, this notion of liquid cooling in the rack it's been around for a while, and goes back to, they used to do it with mainframes, right?
Mhm.
And mainframes weren't inherently scalable as our modular computing that we currently look at with switching and servers and whatnot. So there are some fundamental differences there. But I think at the end of the day, it's going to come down to economics. Is it going to be cheap enough to do it or not? That's generally what everything boils down to. But that's just my view on it.
Okay, and I mean, I guess a neat segue there. Economics. So, in terms of the actual people using 400G, now or early adopters in the future, I guess there aren't that many applications maybe that need it at the moment. But where are they? The hyperscalers, the telcos. How do you see the sort of current market? I suppose.
Yeah, absolutely. So, right now you're really seeing it, in this pandemic world, right? It's in the content. So it's in your video content providers, your internet content providers, everywhere where right now your cloud providers are providing us this wonderful cloud platform that we can communicate across the continents with, right? These are the folks who are seeing they're the folks who are really deploying 400G right now. They're folks who need it. And there's other folks who do need it too, who is, we touched at the first part of the first question is the telcos and service providers. Their network cores are really feeling it, right? Because now they're the next step, right? You get towards the customer, it's all kind of rolling back up. And, they need to increase the capacity of their core due to this rush of bandwidth coming their way. So I think, that's kind of in step in order, right? That's your bottlenecks. If you think of the content as the core, right? Yep. Work your way out from the core.
And I think Ray's point is valid that the service providers, inside of a data center, we talked about the challenges with fiber infrastructure. When you look at a service provider with a nationwide or regional or metro backbone, the optical networks that these service providers operate on have historically been, dense wave division multiplex gridded, so 50 gigahertz or 100 gigahertz grid. The challenge will be that these native 400 gig interfaces, when transponded onto a DWDM network, don't fit on a 50 gigahertz gridded network, and only in some cases fit in a 100 gigahertz gridded network. So For the service provider in the metro and regional and national backbone area, they've got a significant upgrade to do on their ROADM technology and the passive muxes that feed into those ROADMs. In some cases, the optical amplification, will need to be upgraded from EDFA to Raman or to higher end EDFAs or higher performance EDFAs to get these wideband 400 gig lambdas through transport networks. So, not to think about the complexities of just 400 gig itself, but now getting 400 gig across longer distances is even more challenging. So we saw that with 100 gig, and we're just now seeing 80 kilometer and longer 100 gig native links, and so 400 gig presents those same challenges that 100 gig presented a couple of years ago. So not to forget about the SPs and their transport network upgrades. That it's not all router to router or switch to switch.
And I mean, longer term, clearly we're already in the sort of digital age, but on sort of intelligent automation as the catch-all, but under that IoT, all the different sort of activities that are going on with that. Will that drive, I guess, our autonomous vehicles are everyone's favorite example of, vast amount of data needed in real time, etc. And the growth of that edge type application as well. Without trying to confuse with all those different bits, but how do you see the need for 400G, I guess, growing as AI grows? Is that right?
So I think it depends on the type of AI. So when we think about connected refrigerators and connected light switches and light bulbs, those things are super low bandwidth, but require lots of transactions to turn off and on, or notify you that you're out of milk, or that something's been removed from the refrigerator, or that it needs service. So those IoT applications don't require tremendous amounts of bandwidth. So that's not going to be the driver for 400 gig. I think you touched on other types of AI, specifically virtual reality, the offshoots of virtual reality for self-driving cars or automated vehicles. Let's not forget about the evolution of traditional entertainment. So from 1080p to 4K, now 8K content is being developed, and no doubt in a year or two, it'll be 12 or 16K. And the consumer electronics world will continue to evolve with more advanced entertainment options, whether it's gaming consoles or PC games or handheld gaming devices, or the newest self-driving car, Elon Musk's next great invention that he'll wake up with in the middle of the night and create. I don't think we even know what technology evolution beyond, some of these basics. We see the current evolution of what AI looks like, but the Jetsons might be closer than we think, if I can date myself a little bit to that cartoon. But having a Rosie rolling around the house, serving coffee and cleaning might not be so far away. We've got robotic vacuum cleaners now, and those have evolved, and no doubt they will continue to. Ray, your thoughts on that?
Yeah, absolutely. I think if you look at John mentioned the number of transactions and things of that nature, and they don't use a ton of bandwidth, but I think that's just going to impact some of the latency things on the network. But what we're really seeing is a lot of the design around 5G networks, for example, calls for a lot of these applications that you mentioned. And that 5G bandwidth moving out to all the aggregation points on the network, it's massive and compared to other access networks. I mean, they're not messing around, so to speak, with this initial rollout. We're going to run 100 gig out to to a distribution unit. We're going 50 gig to this, between the distribution unit and the central unit. I mean, there's all kinds of like crazy levels of bandwidth in the outside plant that haven't really been talked about at this scale in a very, very long time. Maybe in theory, years and years ago, but now it's, this is the design. And because of this design, it needs to aggregate back up. And, I think that, with push, a lot of governments are putting on 5G networks, That's going to drive a lot of the need for 5G, for 400 gig, regardless if they're using it or not. They're going to need it because of all these, of this massive pipes are aggregating back to a central office or wire center.
Okay, and before we finish, obviously we're talking to you guys from ProLabs. So what are you as a company doing right now in terms of 400G, and without giving away any sort of trade secrets, what else is on the roadmap?
Ray, do you want to talk a little bit about the product line, and then I'll cover high level strategy after that?
Yeah, absolutely. So ProLabs is a full third-party compatible transceiver company. So we're providing 400 gig transceivers in a tested environment for each of our customers that are compatible with the leading network equipment manufacturers on the market. So we provide anywhere from a short reach SR8 transceiver up through a breakout DAC cable, 400 gig to 100 gig DAC cable, and all the transceivers in between right now. So we liken ourselves as a full service provider in this space. So right now we're really working with a lot of our customers who are in that notion of aggregating from 100 gig up to 400 gig. That really seems to be the sweet spot with this technology right now. And we're happy to have the portfolio to help them get there.
And I think to that extent, so Ray mentioned it, we've launched a full suite of 400 gig transceivers and DACs and AOCs. QSFP-DD continues to be a huge focus, and what lies beyond 400 gig. So, we've already started road mapping with our engineering and operations team what the 800 gig transceivers are going to look like. The industry's already talking about what's beyond 800 gig, despite 800 gig not even existing in reality yet. So I think ProLabs is absolutely focused on this business. You look at network equipment manufacturers, transceivers are accessories for them. At ProLabs, transceivers are our core business. It's what we do. We are the very best at it. And it's our entire focus in terms of today's generation, next generation, and supporting legacy platforms as well. So we're very excited to have had this opportunity to interview with you and share with you our thoughts on 400 gig and what lies beyond that.
Yeah, I was going to say, I mean, just sort of finally, you obviously referenced 800. I mean, my background was in the storage industry, so it was fiber channel 1 gig to 2 gig to 4. We never got to the giddy heights yet, to 400. But how useful and over what time frame do you anticipate sort of the 800 and presumably 1600 after that? Are we talking sort of decades or much sooner than that?
I think we have some physics issues to deal with as we talk about 800 gig and anything beyond that. So, there are electrical physics issues with how you get data into a transceiver or into a laser for these higher bit rates. And we talked a little bit about thermal challenges earlier with 400 gig, and those thermal challenges won't go away. In fact, they just get amplified with 800 gig and beyond. So my opinion is that we'll see 800 gig interfaces in the marketplace, maybe late 2021 or 2022. A lot of it will depend on the ability of technology partners to bounce back from pandemic. So I think, this pandemic has not just affected service providers, but the research and development teams that are out chasing these next generation silicon, next generation photonic technologies. So, there's been an industry setback that goes along with, the quote unquote stop work or slow work that was accompanied with a pandemic. Ray, I'd be interested. Do you disagree with those timelines? They might be a little aggressive, but I'd be curious what your thoughts are.
Yeah, to John's point exactly. I think you'll see some early 800 gig, but that's going to be in, certain cloud scale, hyperscale. We build our own server type environments. I think you'll see that's where it'll be, but any type of scale, that timeline of maybe late 2021, early 2022 will probably be where that takes place. From a standard classical NEMS environment, but I think one of the things that John was mentioning about thermal issues, if you think about it, in a 400 gig transceiver or a 100 gig transceiver, you have 4 lasers. In an 800 gig transceiver, you're going to have 8 lasers. So that's going to be it's a lot of things to cool, a lot of things to power up, and that just kind of demonstrates some of the power or some of the issues, right, that are going to have to be overcome.
Okay, gentlemen, it's been great to listen to you. You've learned, well, I've certainly learned a lot about the 400G market, so thanks for that, and really appreciate your time. Thanks very much, Ray, and thanks, Jon.
All right,
Thank
thank
you.
you.